No. Okay. Okay, so we are working on modeling temporal dynamics in Twitter. So essentially the problem is you want to predict a user's interest in a currently trending topic, and you want your model to be time sensitive. So the data we are working with is a 1% sample of all Twitter messages from November to February, last 3 months, and a 10% sample for the next 15 days. So the rough outline is you would like to extract the trending topics from the stream. You would like to extract all the topics that people were interested in this 3-month period. Then supplement with some user information mined through the Twitter API. So there are limits on this, but you can still get quite a lot of information about individual users. And then ideally try to predict what topics would interest a user, and also maybe sentiment, whether it will be positively or negatively influenced by it. So let's look at previous work relating Twitter. So you have several papers which try to correlate the aggregate sentiment on Twitter with anything like the stock market or the performance of a film, or approximately any topic on Earth. So all these things look at the aggregate behavior. We would like to do something more, maybe look at individual user behavior. And the other thing about these models is, like this SNPs paper by 4 authors in 2010, they try to model the probability that a message would be retweeted. So they look at the static network. They look at all the people who did retweet messages over the last 3 months, and there's no time component to the model. So we would like to, so one paper we found interesting was a time-sensitive collaborative filtering model. So it was aimed for the Netflix challenge, not for predicting Twitter ratings, but it was trying to answer the question: how would a user U rate the movie I, let's say, at time t, accounting for the facts that user preferences and movie ratings change over time. So we are thinking of following the approach of this paper with modifications and changes which suit us. So let me quickly tell you what the approach is. It's quite flexible. So you want to model users by users and topics both as vectors in some k-dimensional space, and then you want to quantify the interest of a user in a topic T, and that's essentially your model. You have some regularization, and you want to learn all these P's and Q's. So there are several modeling issues. You want a good topic model. You want a good measure of interest, and you can introduce temporal constraints into the model by having baseline interest variables, like you could have an average interest which says that at a certain time a topic is trending or a certain user has become active at. So all these things can go easily into the model. You can have P's, Q's, and interests dependent on time. So you can introduce several time factors into the model and then see how it's going to do. So that's what we plan to start out with, and it's of course subject to changes and refinements as we encounter problems. And so why do you want to do it? Because we think the static aggregate models are likely to be inaccurate. Temporal modeling should be better in some way. And the time-sensitive prediction of user interests is interesting. So the plan is to maybe train for a month, then test for a few days, and see how performance changes over time, how well does the model do. And maybe test against static models to see if the time component really helps. So the data stream is sparse. It's just 1% of all the messages, and you'll also need to mine Twitter to get complete tweets of select users, and there are limits to this. So one challenge is of course the sparsity of the data, and you need a lot of data to fit the model and to learn everything if you have time parameters. And it's of course a cluster scale problem. It's a very large data set. So we have kind of just started over this, and and we hope to get this done in the next 2 months. So that's just a rough timeline of how we intend to do things. So hopefully I'll have something. So it's just a rough sketch to guide us. Yeah. Okay, that's all.
No, you have 5 more minutes.
Okay, but I think I had just 6 slides, so I stuck to that limit.
Okay, so you're done.
Okay.
Oh, what? I don't know. Are you? Okay. So